Hey everyone, welcome back. Today we'll be looking at 5.1, and this is going to be the first part of 5.1. Chapter 5 is a very long chapter in terms of sections and the amount of parts I've broken sections down into. And we're going to do something a little new this time for different parts within this chapter. Um, a lot of this stuff that we'll be doing is strict review from stuff that we've already covered in Algebra 2, right? But it's been a while, and I want to go over it again. However, if you are the type of student who is good at math or who are typically good at math, and or you remember things fairly well so far throughout the year, I'll give you a brief look at what we're doing today. And if you find that you already know how to do it, then by all means just skip to the homework. And if you know how to do the homework, then everything's good. And if you don't, then you can come back to the video. All right, so we're going to be reviewing foiling and factoring for the most part. So the first thing we'll go into is some basic definitions that I won't have you write down, and then we'll talk about what a quadratic function is. And basically it's just a function where you've got a single variable like y is a function of x, and you can't have like x, y, and z, right? And the biggest power is 2. That's basically the layman's definition. Then we'll talk about foiling, if you guys remember foiling from Algebra 1. All right, so where you distribute this into both and distribute this into both, and then simplify. Then we'll be wrapping up with factoring like this. And we did this back in like chapter 1, I think, where you think of like if you have a quadratic where x is squared and then you've got another some amount of x's, not necessarily, but in this case we do, and then some number here, you think about what multiplies, and that's an x, I don't like to use that, what multiplies to get you 2 but adds to get you -3, what two numbers do that? And then you write that like this. So do you guys remember doing this? If you don't, that's okay, we'll go over it again. But this is basically the gist of what we're doing today, is recalling how to do this. So you'd think of what two numbers multiply to give you +2 and add to give you -3, and that would be a -2 and a -1. Those two numbers will multiply to give you a +2 and add to give you a -3. And so you factor like this, and that's basically it. That's all we're doing today. And your homework will be a worksheet that'll be posted online. So let's go back to the beginning and assume that you have forgotten all this and you want a complete version of today's lesson. So moving back up, we'll be covering what is a quadratic function, what is a binomial, a trinomial, a monomial. We'll talk about how to FOIL when you're multiplying two binomials, and this can be expanded. This process of foiling, I don't really like the term FOIL, because it makes students think that what you're doing is like special to binomials, when all you're really doing is just proper algebra, proper like number manipulation. So then we'll talk about how to factor quadratic trinomials where a equals 1. So let's get on into it. Now again, you don't have to write this down, just get a good sense of it. Maybe write an example or two. Maybe write one of these examples and say these are monomials, and say maybe one term. Shorten it if you like. I know this is a lot and it's pretty basic. So, feel free to, like, your notes are yours. Make sure you just use what you think is best. So a monomial is an expression with only one term. Now terms are like pieces of an expression that are separated by plus or minus signs. So notice how there's not multiple terms on the other side of a plus or a minus sign, right? There's not something over here as well. There's just 4x. So that's a single term, makes it a monomial. Here, -32x to the fourth. Now, there is an x to the fourth and a -32, but they're not separated by like a plus or a minus. It's not just like -32 plus x to the fourth. So everything should be fine. So then you look at something like 102 n squared, where you've got your 102 and your n squared. They're jammed together. They're being multiplied, and so it creates just a single term. And compare that to a binomial where you have two terms, and so you should see that you've got two different pieces that are separated by a plus or a minus. So you've got one term here and another term here. You've got your 3x squared plus your 1. So you've got the first term and the second term, first term, second term. And then here, this looks a little more complicated because it's like x to the third over 6, sure, but really that's just 1/6 x to the third, which is just a single term, all right? And then it's separated with a plus or a minus with another term, and this would be a -4. So you've got your x to the third over 6 and a -4. And then here you've got your 11 over 2 and your 3x over 4. Those are the two terms. And then this is what we're getting into today, is like a trinomials. So an expression with three terms. So in this expression, you've got x squared, 3x, and 2. Here you've got x to the fourth, -6x, and 1. Right? Surely you guys get the idea, right? If you had, 4 terms, you would have, maybe like plus x to the fifth, right? That would be an expression with 4 terms. All right. So a quadratic function is a function of one variable, and by one variable I mean like y, or f of x, is a function of just x, not of multiple variables within the same function, right? Having positive whole number exponents no greater than 2, and this is like after simplifying. Now, you could shorten this in Algebra 2's understanding of math to be just like the biggest exponent you have is 2, right, on some function. And that would probably get the job done for you guys. So if you look, you've got x squared, and then x to the first power, and then no x's, right? This is a quadratic function. So the highest power is 2, then you have an exponent of 1, and then technically you've got like x to the 0 here, because that would cancel and be making just 1. Not necessarily cancel. I don't really like that phrase most of the time, but it would go away because it's just 1. So here are some examples of quadratic functions. You've got 4x squared plus 2x minus 1, biggest exponent 2, and then a 1, and then a none, right? Then here, another situation where you've got x squared, 6x, and 5, right? So these are just showing you some examples of quadratic functions. Now, moving on, we'll talk about foiling. And again, like I said earlier, I don't really like this name. Really, what you're doing is just distributing. So the main idea is to distribute by multiplying each term in the first binomial to each term in the second binomial. So remember, this is a term and this is a term, and this is a term and this is a term. So what you want to do is take each term in the first binomial, so this term and this term, and multiply it by each term in the second binomial. It's just a distributing process. So you would have x times 2x, and that would be a 2x squared. And then you've got x times -1, which is -1x or -x. Then your inside here, or your 2 will distribute. 2 times 2x is 4x, and 2 times -1 is -2. And then you simplify by combining like terms. So you would have a -x and a plus 4x. So that's like -1 plus 4. So that's a positive 3. So you get 2x squared plus 3x minus 2. Okay. Now, the reason why we call it FOIL, in case you've forgotten, or in case you never learned, is that it guides you through what you're distributing to what in a way that's pretty arbitrary, but that's the way they do it. So they say that the F stands for the first terms. So you take the first term and the first term, multiply them, which we did. Then the O is the outside terms, or the outer terms. And so you take this term, which is on the outside, in terms of like, this is one big thing. These are on the outsides of it. So you take the x times the -1, which we also did. Then you take the inner terms, the inside terms, and that would be these two, and multiply them together, which we did. And then the last terms. So the last term of this binomial and the last term of this binomial. And that's how you get FOIL, to remind students of what you're doing. But I think a much better way to talk about it is just to talk about distribution, which is what you're really doing. You're distributing this term to both, and this term to both. And when you think of it in terms of distributing, it allows your brain to scale this up to not just binomials, but maybe trinomials. Maybe, hypothetically, don't write this down, you've got something like this: x plus 2 times x squared minus 3x plus 1. Maybe you're doing this, and here foiling would not make sense. But if you have the idea that you're just distributing each of these terms to each of these terms, then you would be able to do it. You would just take the x times this, times this, times this, and then the 2 times this, times this, times this again. Right, so this is the idea. If you remember it in terms of distributing everything in the first to everything in the second through multiplication, then it doesn't matter how large these expressions are, you'll be able to do it. It might take a while, but you could do it. All right, so let's go ahead and try to FOIL or simplify or multiply these binomials together, this expression. So if you think you got a handle on it, go ahead and pause the video and see. And if not, then I'll walk you through it. So first things first, you distribute the first term in the first binomial to everything in the next binomial. X times 3x is 3x squared. X times negative 5 is negative 5x. Then distribute the negative 3, don't forget the negative, to everything in here again. So negative 3 times a positive 3, x, is a negative 9x. And then negative 3 times negative 5 is a positive 15. And now you combine like terms. You've got your 3x squared from here. Then your negative 5x and your negative 9x combine to give you negative 14x. And then you still have your plus 15. And that's it. Okay? So here, all of this is in your notes already, okay? I wouldn't write all this down. I would just write factoring quadratics when a equals 1 and then write this format down. So this is our, like, I forget the specific names of these forms. They're really arbitrarily named. I don't know if this is the general form or standard form. That's not relevant. So when you've got it in ax squared plus bx plus c and your a is 1, that's what we'll be factoring. So like I said, don't write all this down. You've already got this in your notes. It's like 1 point something. What two numbers multiply to give you c, the final number here that doesn't have an x with it, but add to give you b, the number tied with the x to the first power? That's the idea. And the factored form will consist of two binomials. So let's go ahead and look at this. Now, we did this right at the very beginning of the lesson, so if you have already seen this, then, we're going to do it again. So this is like your c value, and this is like your b value. And there's a 1 here. That's like your a value. And that's what we're learning today. Factoring when a equals 1. So notice how you just have x squared. So secretly you have a 1x squared. This is the type of quadratic we'll be learning to factor. Or relearning how to factor. So what you're doing is you're trying to think of a number that multiplies, actually two numbers that multiply, wow, I'm just so bad, multiplies, and I swear this summer this is the only time I write anything, so it's pretty atrocious. Multiplies to give 2, a positive 2, but adds to give negative 3. All right, so you don't think of two numbers that multiply to give you positive 2 and add to give you negative 3. Now, my foolproof way of doing this is to look at the factors of your number by itself. Factors of 2, numbers that can multiply to give you 2. And those are just 1 and 2. But you also have to consider negative 1 and negative 2. So, because those also multiply to give you positive 2. So what I would do is I would start by writing out, if you're bad at this, if this does not come naturally to you, start by writing out all the factors that give you positive 2. So 1 and 2, and negative 1 and negative 2. And then see which of these factor pairs add to give you negative 3. So try to think about which ones add to give you negative 3. Well, does 1 and 2 add to give you negative 3? No, that adds to give you positive 3. But negative 1 and negative 2, those add to give you positive 3, or negative 3, excuse me. So you would factor it. It would be x and then this number, and then x and then this number. So it'd be x minus 1 and x minus 2. And there is your answer. That's your factored form. Okay, so let's move on to another one you've not seen. So here, you've got x squared plus 8x plus 15. So think of numbers that add to give you this, but multiply to give you this. And again, a way to do this is to look at this number that you're trying to figure out what multiplies to get it, and write out all the factors of 15. So that would be 1 and 15, and always start with 1 in the number, 1 and 15, and then you've also got negative 1 and negative 15. Does 2 go into 15? No. How about 3? Yeah, 3 and 5, and negative 3 and negative 5. And then 4 doesn't go into 15, and 5, we're already back to 5. So these are all of the factor pairs of whole numbers that will give you 15 when you multiply them. So go through them. If you're bad at this, I really do encourage you to do this method. Go through all these and see which one of these pairs adds to give you 8. And you should see it's obviously 3 and 5. Those add to give you 8. And so you should now know your answer. You've got a 3 and a 5. And so it's x, and then that's a positive 3, right? A positive 3 and a positive 5. So it's x plus 3 and x plus 5. And that's it. If you have any questions over that, let me know, or start the homework, and then if you have questions, then let me know. All right, I'm here to help. So your homework is a worksheet. I'm sure you know how to find it and what to do, and I'm also sure you know the due date. This is the start of one of our longest chapters, and so hopefully you stay caught up and on pace. All right, anyway, see you next time.